Hi there, in this video we're going to be finding the critical points or the critical values for this particular function. Now the first step we want to take is finding the derivative of this. So the derivative of this term here is going to be equal to 2x to the 5, add, then the 5 will cancel out if you bring it over there, so it's just going to be a 4x to the 4, then add. This will give me 2x to the 2x cubed. And now that we found the derivative, we have to recognize that x is going to be defined for every value of x. The domain is every value of x. So the only point at which we can find a critical value then is basically the solutions to this function, because critical values are usually found where the derivative is either undefined or where it's equal to 0. It's never going to be undefined. Therefore, we need to set this function equal to 0. Now, the best way to do this is to factor it out a bit more. So we can see here that we can factor out a 2, and we can factor out a x cubed. So let's do that, x cubed. And that would leave me with a x squared. Add, then we just have a 2 here, 2x, and then we have just a 1. And all of this is going to be set to 0. So that automatically tells me that when we set this particular term right here to 0, we have x, it can only be 0 when x is equal to 0. So one of our critical points then, or critical values, is going to be when x is equal to 0. Another one is going to be when this term here is 0. So what's this term? Well, if you factor this out, you can see it's going to be x plus 1 and x plus 1. That would mean whenever x is equal to negative 1 in this case, then this term right here is going to be 0, because negative 1 means 0. 0 multiply anything there will give me a 0, which means x is going to be, or the other critical point or term, or rather critical value, is going to be when x is equal to negative 1. And that's the solution. Thank you for watching. If you have any questions, feel free to ask in the comment section below. And I do hope you're having a fantastic day.